Okay, so for question B in part 4, again we're doing the Taylor expansion. This time our function is cube root of x, and our a is equal to -3. So we're just going to use our formula up here to get our the first three terms in our Taylor expansion. So first term, just plug in -3 to the function. So we are going to get cube root of -3. Okay, so the next term is we have to take the derivative of this, plug in -3, and multiply by x minus a. So our f prime of x, this is x to the 1/3 power. So we're going to get 1/3 x to the -2/3. In order to keep this consistent with how I'm going to write the rest of these, I'm going to write this like let's figure out the second derivative now too, because we're going to have to use it for the next term anyway. I'm going to use this form to take the derivative of because that's easier. So we would multiply down by the -2/3, we get -2/9 x to the -5/3 by bringing the power down using the power rule for derivatives. And let me write that in root notation so that this all looks consistent. So this would be -2/9. So this would be 9x cube root of x, x squared. So basically, since it was going to be cube root of x to the 5th, I just factored out one of the x's that you can there. Alright, so let's use these to get the next two terms. So if we plug in -3 to our derivative, so -3 squared would be 9, so we get 1/3 cube root of 9 times x minus a. X minus a would be x plus 3, because our a is -3. And 1 factorial is 1. Alright, and the third term, here's our second derivative. We're going to plug in -3 to that. When you plug in -3 here, you're going to get -27 cube root of 9, -2/-27, the negatives can cancel out. So we're going to get 2/27 cube root of 9, x plus 3 squared, and we'd have to divide that by 2 because we have a 2 factorial, which just means that these are going to cancel out. So, written most simply here, we're going to have cube root of -3, we're going to have x plus 3/3 cube root of 9, and over here we're going to have plus x plus 3 quantity squared over 27 cube root of 9. And these would be our first three terms. So again, just following the Taylor formula. Sometimes you're going to get functions like this where the derivatives start to get pretty complex, but you're usually only going to be asked for a limited number of terms, so it's not going to be too bad. So there's our first three terms of this Taylor expansion.